Okay, so if we see a word problem and it says write an inequality for the third side, then we know that this number could be more than one number. And in fact, we can kind of imagine that these two sides could open up that angle, and eventually x at some point is going to get too long. We also know that these two numbers, a side 7.2 and 6.2, can collapse to a point where x can just be too small. So this formula allows us to figure out, well, what would be a possible range of values for the third side? And it's really a formula of just adding the two sides that we know about and subtracting the two sides. So if we subtract the two sides, we get 1. And if we add the two sides, we get 13.4. So any number between 1 and 13.4 would be an appropriate number to still allow this to be a triangle. Cool. Now another type of question that they can ask is ordering the sides least to greatest. Oh boy. Okay, so on the test there'll be a question like this, A, B, C. And where some students need some extra help is knowing that this angle here, yeah, we normally call it angle A, but it can also be called BAC or CAB. So I'm going to call it BAC. You should focus the letter A there to help you remember that that's the angle we're talking about. And the angle B could be called ABC or CBA. So I'm going to call it CBA. And again, see the letter, I'm talking about this angle right here. And then last but not least, this angle C could be called BCA or ACB. So I'm going to call it ACB. Now we need to be able to find these numbers and then once we do that, be able to order these sides least to greatest. So this is a side, this is a side, and this is a side. So in order to order the sides least to greatest, so let's put some numbers in here. Let's imagine that this is 33, and that would be printed on the test. And this is 57. And this is 88. So imagine this problem is printed on a test, and you not only need to fill in these, but you need to order them least to greatest. Okay, so let's do it. We should notice that this triangle, I can figure out what goes there, because that triangle, every triangle has to, the angles have to add up to 180. So I have this angle, angle A, plus the angle 88, plus the angle 57 have to add up to 180. So I combine like terms. And I get angle A is 35. Okay, so I solved one mystery, BAC or CBA, or where I see A in the middle. That's going to be 35. Now, I noticed that 57 and 35 actually make up this whole angle right here. So ABC or CBA is actually these two angles added together, 57 and 33. Ooh, and that's 90. So that's interesting. So when I look at this triangle, it's actually 35, 90, and this angle is the only one missing. So I can put angle C plus 35 plus 90, and those three should add up to 180 if I look at the whole triangle. So 35 plus 90. $125. And I get 55. So this angle would be 55. And I'm not quite done because I need to order these sides least to greatest. And so again, I can work off of this picture, or I also made a new sketch over here that might help. So to order the sides least to greatest, you focus in on the smallest angle, and this would have to be the smallest side. If this is the smallest angle, this would have to be the smallest side, and I'm gonna call that BC. Then I look for the next smallest angle. So it looks like 55 would be the next smallest angle. 55 is the next smallest angle. So that'd be side AB. And lastly, 90 is definitely the biggest angle. So this side opposite that would be the biggest one. And this is where it gets a little tricky. I got to think about both of these because that's what's creating this big side AC. So I've solved for the missing angles and I've ordered the sides least to greatest. Looking good. Now, a scavenger hunt problem is also going to be on the test. So I'm just going to draw a scavenger hunt problem. And it just looks like a regular old problem. And a lot of times they'll give you like maybe this angle and this angle, maybe this angle. And then you got to work your way around and solve for some of this missing stuff. So let's figure out what would make sense here. So let me make sure I didn't give too much information here. I'm gonna work it through like this, actually. Okay, so we know if that's 46 because of vertical angles. We know if that's 22, that's 22. So definitely the problem is gonna have to give me a little bit more information, but I am noticing something. I'm noticing this whole thing is a triangle. So this big angle has to be whatever's left over from there. All right? So let's say that this angle, so let me see what that would be. Let me just do that really quickly. Okay, so that would have to be 112. So let's say this angle is 105. So it's pretty close to what I started out with. If this angle is 105, I can figure out what this one is. I can also figure out what that one is. So if I try that out, 180 minus 105, I get 75. Well, now I have all the information I need for this triangle. So I know 46 plus 75 plus whatever this one is. Let's say I call that X. All those should add up to 180. So this would have to be 59. And again, there's two ways to get this, but I can work my way through this problem. This is definitely a triangle. And it should, this triangle, and those three numbers, 105, 22, and that number should all add up to 180. So let's call that Y. Y plus 105 plus 22, all should add up to 180. And I get 53. Now I can double check my work. 46 plus 22 plus both of these angles make up the big triangle. 46 plus 59 plus 53 plus 22 all add up to 180. So now I'm feeling good. Now, last but not least, what if they put a little z out here? So this was our x, this was our y, and we solved for those. X was 59, y was 53, and we have to figure out what z is. Well, notice z makes a straight line with the angle 22. So 22 plus z has to add up to 180 because they're a linear pair. So to find that out, we just subtract 22 and we get 158. So 158 makes sense here, and we've solved for all the variables. We'll get lots more practice on these, but that's a good example. Now, last but not least, one of the problems that we know will be on the test is they'll give us an equation and a point. Now, if they say the word parallel, I'm going to just keep the slope the same. But if they say the word perpendicular, I have to take that slope and make it negative if it was positive. Thanks for joining us.